Hello and welcome back. I didn't quite make it to the end of this example in the last video, so let's quickly run through it again. So we want to take the antiderivative of x plus 1 times x minus times the square root of x minus 1. And we recognize that, okay, we've got a sort of a product in here, and this is going to be a hard derivative to take with multiple parts. So we'll use integration by parts. Here's the formula. So we have to identify the best u and v to make this integral work out. Remembering that the second integral we want to make as easy as possible. So we chose x plus 1 to be u, since the derivative, du, is just going to be dx. And that made this, the second integral is going to be a lot easier. And once we identify u and dv, we find du by taking the derivative. We find v by taking the integral of dv, which was fairly straightforward. But now we have we've plugged everything in, and we have the integral of x plus 1 times the square root of x minus 1 is going to be x plus 1 times 2/3 x minus 1 to the 3/2 power. This was v. And we have minus minus the antiderivative of v times du. So here, the u dv all works, the uv up front works exactly the same. So it's going to be x plus 1 times 2/3 times x minus 1 to the 3/2 minus this guy. And so first of all, we have a constant times the function on the inside. So we'll just pull that out. And now I want to take the integral of the antiderivative of x minus 1 to the 3/2 power. So this is going to be x minus 1 to the 5/2 power, because we're going to raise it to the 1 higher power. And then we'll pull down that power, and we're going to divide by that. So there's an integral. Now that we've taken the integral of everything, we should remember, okay, we've got a plus c out here, and we can simplify this just a little bit. So maybe I'll move the 2/3 to the front. It's nice to have our constants at the front, so we can just collect all of them up. Minus 2/3 times 5 times 2/5 is 4/15 times x minus 1 to the 5/2 power plus c. So there is our final answer. So again, the hardest part about all of this is identifying what your u is and what your dv is. But once you do that, the rest should just come out of the wash. Let's do another example. This, I think, is a fun example. This shows just how tricky sometimes integration by parts can be, but it's also just kind of neat to see this work out. Maybe I'll make this a little bit nicer. So we've got the natural log of x dx, and we know that we can take the derivative of natural log of x. Derivative of natural log of x is going to be 1 over x, but we never saw how to take the integral of the natural log of x. And honestly, the integral is a bit tricky, but I'll show you the trick, and I think it's just a lot of fun, quite neat. So we've got we're going to use integration by parts, even though it doesn't look like there's a product rule in here. And the way this will work is we've just got to be clever when we're choosing our u and our dv. So even though it doesn't really look like there's two functions in here, there kind of are. We've got the natural log of x as one function, and then the dx is going to be another differential in here. So for the u, I'm going to say that that's going to be the natural log of x, and the dv is just going to be dx. And maybe the best way to write this would be, this is going to be 1 dx, rather than just dx by itself. Now there's a reason why we would do this. the natural log of x is something that I can find the differential for. I can take the derivative. So the derivative of natural log of x is 1 over x. And to make it a differential, this is going to be dx. Lastly, I have to find v. So what function is 1 the derivative of? Well, the derivative of x is 1. And that's it. So by choosing these guys, we can now come back and use our formula. So the integral of u dv is u times v minus the integral of v du. So let's start simplifying. So first, natural log of x times x. I'm going to rearrange this so it's a little bit easier to read. So this is going to be x natural log of x. And then this guy, we're going to subtract the integral. Well, what's x times 1 over x? Well, they cancel. X divided by x is just 1. So this is just going to be the integral of 1 dx. And we already said that the integral is just x. Can't forget our plus c. And that's how you take the integral of natural log of x. It doesn't feel like it should be that complicated, but when we take antiderivatives, they do pop out in some weird ways. So let's do this guy here. So we've got x e to the 7x, and this looks like an integral that we had before. Again, we've got a little bit of a product rule going on in there, so this might indicate that we want integration by parts. There's no u sub, there's no nice u sub that we could put in there to make this a bit easier. So after we do integration by parts, this will be a lot easier. But notice that this is an actual integral, not just an antiderivative, because it has bounds. 0. So we will have to plug in our bounds at the end and see exactly what we get out the other side. So again, with our formula, maybe I can write that up here again. The integral of u dv is going to be u times v minus the integral of v du. We want to find the u in the original integral that when we take the derivative makes a simpler integral. And here, out of everything in here, the thing that simplifies the most, the thing that goes away when we take the derivative, is going to be x. So if I take the derivative of x, I just get 1. And that means that the rest of this has to be my dv. And we've got this constant up here, so we'll have to be a little bit more careful. The integral of e to the x is e to the x. But when I take the derivative, that 7 is going to pop down. So in order to compensate for that, this is going to be 1/7 times e to the 7x. Again, if I take the derivative of this with the chain rule, 7 is going to pop down, and they need to cancel out. So let's start plugging in our u's and our v's. So we're going to take u times v, so u times v. And here is where I can already say, okay, it's not just going to be this, but I have to plug in my 1 and my 7. Or sorry, my 1 and my 0 and my 1. Those are the numbers. But we still have to subtract another integral, and again, we just want to use the same bounds everywhere. V du. So v is going to be 1/7 e to the 7x times du, which is just 1 dx. So maybe I'll just continue this down here. This will be our scratch work. So I'll plug in a 1 into this guy, and I'll plug in a 0, and we'll subtract them just like we normally do. If I plug in a 1, it'll be 1 times 1/7 times e to the 7 times 1, minus, when we plug in a 0, 0 times a 7th e to the 7 times 0. So that is this first part, minus, when we take the integral of 1/7 e to the 7x, but in the same way, we're just going to get 1/7 the e to the 7x. When we take the integral of that, it's just going to be 1/7 e to the 7x. And again, we're going to evaluate this from x is equal to 0 to x is equal to 1. So this is going to subtract all of that guy. So let's simplify this first bit. 0 times anything, well, that's just 0. So this first bit becomes 1/7 e to the 7. And we're going to subtract this guy. So we'll plug in a 1 into there. So 1/7 times 1/7 is 1/49 e to the 7th. And then we'll subtract when we plug in a 0. Minus 1/49 e to the 7 times 0 power, but that's just 0. So simplifying, we get 1/7 e to the 7th minus 1/49 e to the 7th. E to the 0 power is just 1, and I'm subtracting a negative number, so it's going to be plus 1. And this could be our answer. However, we also see that I could simplify this first one a little bit. This would be 7/49, so that would be the same thing as 6/49 e to the 7 plus 1. Both of those are the same. And I might not have time to do this next one in this video, so we will do one more example in one more video.